Okay, good Friday morning, everyone. It's great to be back here with you all after a couple of weeks off in the beautiful city of Medellin, Colombia. My name is Tim, and I will be your host for this week's episode of Backyard Naturalist, brought to you by the Urban Ecology Center. From my screen to yours, we are here just about every Friday morning at 9 a.m. to discuss the nature in and around our collective backyards. Collective backyards is a reminder to me of a nationwide movement led by Doug Tallamy to basically turn our collective backyards into a national park. I guess not turning it into, but just understanding the importance of all of our backyards. And so he calls it the homegrown national park. And basically, if a huge percentage of the land in the US is privately owned. And so even if you're like me and you have a postage stamp sized backyard, if you combine 1 million people with a postage stamp sized backyard, you get a pretty big land area. And so the idea is that, collectively our backyards can have a major, major impact as an ecological community, um, particularly if you make a portion of your backyard, amenable to wildlife. So native plants, focusing on the features, the ecological features in your backyard. And again, there's so many backyards in the world, you don't have to do a lot, but collectively, that's a major, major area. And so you can Google it, Google the Homegrown National Park. Um, I don't know a lot about it, but I think you can kind of like register your backyard and we'll have to take a look at it. But that's just one of the many importances of our backyards that we gather here every week to look at. And today we're looking to the ceiling of our backyards. The ceilings in our backyards are an ever-changing picture of sun, moon, planets, stars, meteors, spacecraft. And one of those visitors is Mars, the red planet. So the the place where men are from, the place where nothing ever happens. Um, and if you get that reference, I'm very happy. So everybody, I hope you can sit back and relax, if you can, as we explore the stories from our space neighbor Mars in episode 48 of season 5 of the Backyard Naturalist, The Fault in Our Mars. As always, thank you for joining us. We say it every week. We're glad you're here. Whether you're with us here live this morning on Friday morning or watching this in the future, my future self and my current self both thank you for watching. And we are almost done with another season. And after today, there's only 4 more episodes before we kick off season 6. So we hope you continue that journey with us. If you are a subscriber, thank you for that support. It keeps us accessible to the greater community. And we hope you continue that journey with us into the new season. We're rolling out a couple changes for next season that we hope you will enjoy, and details are coming very soon. I am also really excited to introduce a brand new college level course at the Urban Ecology Center. It's mammalogy course that Amanda will be teaching this fall. It's an 8-week course, and she'll be teaching mammal evolution and structure and function and diversity and ecology and behavior and conservation. Uh, Participants will gain hands-on experience identifying mammals via track and sign. And in field methods used for surveying and researching mammals, it will be split between a lecture portion and a lab portion. And by the end of the course, participants should be able to identify mammals living in Wisconsin and describe their ecology, their behavior, their habitat requirements. They should be able to summarize key characteristics of mammals generally and distinguishing features of major mammal lineages, describe current research techniques used to study mammals, and understand conservation issues mammals face today. So it's a college level course that is going to be made fun and interesting and scratch that itch of learning knowledge. We are mammals. The course will not focus on humans, but our mammalian cousins with whom we share the land, the sky, and the water here in Southeast Wisconsin and beyond. So fantastic opportunity to work with a fantastic instructor, and I hope you will consider joining us for this course. So for more information, you just contact Amanda, hit her up for some of the knowledge she's going to drop, or you can visit the Urban Ecology Center web page. And um, before we look at Mars, there's more and continued news from the world of space observation and exploration. So we've been following this story for months now, the journey of the stranded astronauts on the Boeing Starliner mission. They're still up there, they're still waiting. They are now on day 57 and counting on what was supposed to be a week-long mission. So Sunita Williams and Butch Wilmore have been up on the space station 8 times longer than they were expecting. Um, I guess gives a little bit of a new meaning to delays that a lot of us experience on the ground in airports. But they are patiently waiting as teams on the ground are trying to figure out how to safely bring them home. So that's a good reason to wait on the Boeing spaceship that brought them there, but has since been beleaguered with problems. There's a propulsion system leaking helium, and they had 5 malfunctioning thrusters, which doesn't sound all that good. So there's still no timeline set for return, and the 2 astronauts have just kind of ingratiated themselves with the 7 astronauts that are already there, helping them conduct research, like a dinner guest staying much longer. The story is still unfolding very slowly, and we will keep an eye on that and wish them a safe return home soon. We are also still waiting for a launch date for the Escapade mission, which is a NASA-funded mission to bring 2 orbiters to study today's featured planet, Mars. So the orbiters are operated by the Berkeley Space Sciences Laboratory, and they are studying the magnetic bubble around the red planet. And we'll be talking a little bit about the magnetic bubble later in the program. We've got some great meteor action going on now and coming up soon. Pretty good meteor action, I should say. The brightness of the moon over the next couple of weeks isn't helping, but we've just passed the peaks of 2 meteor showers, the Southern Delta and the Alpha Capricornids. They peaked about the same day. They're smaller, and they're talking like 5 meteors per hour, but there's 2 of them, so that's maybe 10 meteors per hour. And with it being August, this is the time of year that I always love to look for the Perseid meteor showers. This was the one we always look for on family camping trips up north. I have very fond memories of bringing sleeping bags to the shores of Crystal Lake and lying on the grass looking for shooting stars as I went in and out of sleep. This year, the peak is August 11th and 12th. The moonlight doesn't create ideal conditions, but the shower can easily produce 100 shooting stars per hour. So get outside if you can. It's always great if you can find dark skies after midnight or before sunrise is the best. And we are here to talk about Mars today. And I would like to again reference my regular go-to source of information about stuff you should know, which is the Stuff You Should Know podcast. Really fun journey into the knowledge of things that we want to know about, whether we know it or not. It's a wonderful podcast, and I do continue to try to have folks tune into the Bird Joy podcast. They finished their first season, but you can go back and listen to all of them. It's just a really delightful. One of the hosts is local here in Madison, Dexter Patterson with the BIPOC Birding Club of Wisconsin, which is having an event here in Milwaukee soon in Lake Park. So you can check out their website. These are my two go-to podcasts. So, the story of Mars can be traced back to the creation of our solar system. Technically, it goes back to the singularity and the Big Bang, but if we start at a more tangible event, it's the creation of our solar system. If you believe NASA, our solar system formed about 4.6 billion years ago from a dense cloud of gas and dust that was just basically hanging around in space between other stars. Possibly the debris of a recently exploding star called a supernova, possibly energized by the supernova to form. But basically, you have all this debris, and like after a big mess, you're kind of sweeping it all together. But the sweeping is done by gravity, and this cloud is collapsing into a spinning, swirling disk of material. The stuff at the center, 99% of the stuff at the center forms our star, the sun, with the largest mass, and where the gravity became so powerful that the pressure turns hydrogen into helium, which releases a tremendous amount of energy. And we do have an episode on the sun in our archives, one of my favorites. So the sun forms in the middle, but then there's all this other matter farther out. Gravity is acting on that, and that matter is forming additional clumps, and the clumps are starting to smash into each other, forming larger and larger clumps, sometimes forming moons, and then the ones that grow big enough for their own gravity to shape them into spheres is what you get when you get planets and moons, the spherical forms. And then what doesn't become a planet or a moon uh, becomes the leftover asteroids, the comets, the meteors, which aren't that spherical shape. So the closest masses to the sun become planets. The with pretty similar stories. All of the stories, Mercury, Venus, Earth, and Mars, have a very similar evolution timeline. So we often compare these planets to the one we live on because they're formed in roughly the same way. They went again through similar processes, especially at the beginning. Um, and partly because of this, we continue to look for life or evidence of life on all of these planets. And Mars in particular, maybe to a lesser degree, Venus and then Mercury, but it's possible that and likely that all of these planets at one time had very Earth-like qualities. When you look at the atmosphere and the water and the potential for life, so they're known as the terrestrial planets because they all have solid surfaces, unlike the gaseous giants farther out. But then after formation, eventually they all take very different turns, which is why they're very different today. We do have an episode in the archives about Venus, the stories of Venus, which was a really fun one to do. And the story of Venus changes quite a bit. It's very possible, likely, that there was life on Venus, that Venus was very Earth-like at one point, atmosphere, life, oceans. But then it took a pretty nasty turn in terms of life. Um, and that's a theme of the story when we look at these planets. Um, Today, the star of the show is Mars. So for the next 30 minutes, yes, Mars, you will become a star. Uh, it, it the story of Mars is very similar to Earth but there's two major differences. There are two major plot lines that really change the story of Mars. The first is its size. It's half the size of Earth. So the processes that are happening on Earth are happening on a smaller planet, and that's going to become important. And then, of course, it's quite a bit farther out from the sun relative to Earth. So as the solar system was forming, these closer planets took about 100,000 years to accrete. There's a stage of accretion. So all that gas and dust in the nebula is starting to pull together by gravity. As more mass is pulled together, that gravitational pull gets stronger, which means more material is pulled in, and you kind of get a positive feedback loop. With that pull, you get some degree of spin, rotation, tilt, and that's the thing that really differentiates planets and moons is that there's enough material to cause a strong enough gravitational pull to make that planet round or spherical. So if you think about the center of gravity being at the middle of the planet and everything is pulled to that center, the geometrical shape that allows that is a sphere, because all of these points then are about as close to the center as they get. You don't get, big points that are farther out, at least not, in a major way. So with more accretion, the pressure at the center of these spheres heats up, not to the degree of the sun, but you get quite a bit of heat, and this happens in all of these planets. So you get that often a molten core. When Mars was young, the pressure and heat of that gravitational pull formed a molten core just like on Earth, only smaller because the planet is about half as small. So the Earth's core has a radius of about 2,200 miles, and Mars is about half that. And the core of Earth is primarily iron and nickel, because during that accretion, it's these heavier, denser materials that are pulled more strongly to the center by gravity, and the lighter elements kind of float to the top. So the Earth has both a solid inner core and a liquid outer core. And it's the interplay between these layers that gives us our magnetic fields. which allows us to navigate and have northern lights. The core of Mars also has iron, but it's not the iron nickel core that we have. It has sulfur and oxygen in the mix. Again, it's not as strong of a pull. We are pretty sure that the core of Mars today is not molten. Mars does have a very weak magnetic field compared to Earth. But early on, Mars had a molten core, a much stronger magnetic field, and above the core you have a mantle, which is full of less dense materials, like iron and magnesium silicates. On Earth, they take on the consistency of like toothpaste. And then so on Earth and the early days of Mars, this magma is pushed up to the surface, the heat, convection, and it becomes lava. And so on both Earth and Mars, you have histories of very dynamic volcanism. But then one of the differences between Earth and Mars shows up when you look at the crust. On Earth, the crust is, again, this is the least dense material. And on Earth, you have both oceanic and continental crust. It's basically floating on top of the mantle. But with the dynamic nature of the Earth, these plates are moving, they're upwelling, there's subduction, and you have the boundaries between different plates, that the plate tectonics that gives us earthquakes and volcanoes. Mars does not have moving plates. The crust is a solid layer around a mantle, kind of more like an eggshell, which of course can crack, but it's stationary relative to the rest of the planet. So you still get volcanoes popping through, but you don't have the moving crust moseying around like the Earth's crust. So again, rough comparison of the two planets. The easiest thing to see is the difference in the size between two planets. But other than that, there's a lot of similarities. If we go back to that accretion phase where these layers are forming based on density, the least dense materials are the gases. And so when the core and mantle are forming and the crust, the gases, the least dense gases are being pushed out and they're kind of floating on top of the crust, and that's what becomes an atmosphere. And so especially when magma erupts on the surface, you have a lot of release of gas. And we know that from our volcanoes. You have a huge amount of gas release. And each one of those volcanic eruptions is putting more gas into our atmosphere, which is making a thicker atmosphere. The early on, both Earth and Mars, the atmosphere was building, and massive amount of gases, primitive atmosphere. The primitive atmosphere of Mars almost certainly had water vapor. And then over time, the gases heat up. You have the greenhouse effect on both planets, increases the temperature combined with water and water vapor in the air, and that results in rain. It results in rain on Mars the same way it would result in rain here on Earth today. Only that there's no rain now on Mars, but in the early atmosphere, you did have rains. And because of that, it's very likely that early Mars had liquid water on the surface that formed oceans. Mainly for a reason we'll see later, there's one major ocean, but you had oceans on Mars. And, very likely, potentially an atmosphere that supported life, whether or not it had it. At the same time, both Earth and Mars and all the planets are being pounded by meteors as that atmosphere is building up, the protective atmosphere, the protective magnetic field. But for a long time, there's just this massive pummeling of all of the forming planets. So, you see that on the moon, you see that on Earth, you see that on Mars, the craters, the basins, except on Earth, the process of erosion and oceans kind of smooths out that violent history. But you can still see it, when you dig down and look layers and the massive craters that were here. It's likely that our moon formed when the Earth was hit with a very large meteor that sent, kind of like when you see videos of water dropping in a water drop hitting water, you have that little like doop, and the little part of the water comes up. Something like that probably happened with Earth, and that little doop became the moon. But from a historical perspective, at this point, which is about 3 billion years ago, this very well could have been what Mars looked like, very similar to Earth. Um, but that 0.3 billion years ago is a major player in what happens next. So on Earth, 3 billion years ago, you have the great oxygenation event. So you have algae pumping oxygen into the atmosphere that has a huge effect on the rest of life, and allows for terrestrial life, plants, lungs, or plants that produce more oxygen, which allows animals to develop lungs. And then you have this explosion of life and life supporting oxygen here on Earth. On Mars, fortunately or unfortunately, about the same time, you have what is known as the Great Desiccation Event. It's probably Mars just wasn't big enough to keep that furnace going in the center, which was keeping that atmosphere going. So the Martian volcanoes go dormant. Pretty much all of that heat becomes pretty much all but released. The atmosphere then, there's not enough gravity to hold on to that atmosphere. The atmosphere starts to thin, and without more gases being pumped out, the atmosphere starts to go. You lose your magnetic field. Temperatures drop sharply, and so the atmospheric water either gets lost to space or freezes and becomes part of the permafrost. So there is quite a bit of frozen water on Mars, but there's no liquid water. And essentially Mars becomes what we would call a barren planet. If there was life, it probably didn't survive, probably. But if you look at Mars today, it does look pretty barren and dry, from the Earth's perspective. So not completely devoid of structure. So there's three major areas that are described by, would you call them astrogeologists? Maybe. You start with the Southern Highlands. And so this is a very vast, practically half the planet elevated area. It's ancient. It was formed during the early active phase of the planet. It still bears the evidence of all those craters and volcanoes. And I promise you, this is the coolest thing you're going to hear all day. If you didn't know this, you might know this already. But in the Southern Highlands, there is a volcano called Olympus Mons. It's not only the highest point on the surface of Mars, it's higher than the highest mountain on Earth and is the highest point in the known solar system. So for perspective, the highest point on Earth is Mount Everest, 29,032 feet above sea level, still rising. Mount Everest is not the tallest mountain on Earth. That claim goes to Mauna Kea in Hawaii. So Mount Everest is 29,000 feet. Mauna Loa is 33,500 feet base to peak. That's almost a mile taller than Everest. So Everest is the highest point above sea level. Mauna Kea is the tallest mountain on Earth. So that's pretty impressive. Both of them are pretty impressive. Then you look at them relative to Olympus Mons on Mars. So remember, Mars is half the size of Earth to begin with, but it has the largest mountain in the entire solar system. It's 16 miles tall. Everest is 5.5 miles tall. It's 3 times taller. It's almost 3 times as wide as the base of Mauna Kea. 370 miles long compared to 140 miles. So very, very large mountain in the Southern Highlands of Mars. The other major portion of Mars is in the northern plains, and this is a little over a mile lower than those highland areas. It's a much flatter area, but because of that, and some, like, if you look at the flatter areas of the western part of the US, back when there was a dynamic surface, it created a lot of canyons. So these massive plateaus that get eroded, and then on top of those plateaus, you have formation called cinder cones, which is a result of the upwelling of the mantle from the days of volcanism. But not to be outdone by Olympus Mons, the northern plains also has a very impressive valley, with a system of canyons. So this is Valles Marineris. On Earth we have the Grand Canyon, which is impressive, but completely dwarfed by Valles Marineris. So it's 370 miles wide 26,400 feet deep and about as long as the continental United States. So just a huge trench system. And again, on a planet that's half the size of Earth. And then the third major areas are something that we're also familiar with here on Earth, and that's the polar ice caps. So these are dynamic formations that grow and shrink with the seasons, just like our own. They're not made of ice water. They're iced carbon dioxide. So basically dry ice. The polar caps on Mars are caps of dry ice. And again, they move, they shrink, they grow based on the season. And they underneath the dry ice caps, there is frozen water. In fact, there's frozen water, we recently learned, everywhere on Mars. But the ice caps themselves are dry ice. And then this region is surrounded by a large system of dunes. Again, the great desiccation. So if we kind of go back to this image of what an early Mars might have looked like, now you can see in this image the clear difference between the highlands and the lowlands, where the water would be forming and eroding and creating those canyon systems. If Mars were still like this, the similarities would continue. So Mars has seasons just like Earth. The tilt of Mars causes seasons. A day on Earth is almost exactly the same as, I think they call it a sol on Mars, a day on Mars. It's about 43 minutes longer, the Martian day than the Earth day. But the year on Mars is about twice as long as the Earth, because much larger orbit. So the Martian year is 686 days. And that means the Martian seasons are longer. And this is important if we do try to live on Mars, if we try to have a colony on Mars. One of the many reasons that living on Mars would be difficult, one of the many reasons, is seasonally, the entire planet becomes enveloped in a major dust storm. So this happens in spring and early summer. You get the rise of temperature, which would normally produce these convection cells of water and rain. But without the water, it's causing the dust to rise and thicken in the atmosphere. Then that causes temperatures to rise. It causes differences in temperature and pressure, just like on Earth. And then so you get massive windstorms that are full of dust. And on a regular basis, this is a 120-mile-an-hour sustained windstorm that is planet-wide. So, you can look at, in September, what you see, the features that you see in June, other than the ice caps, you see pretty much the whole planet has to go through this, several month period of a massive dust storm. So that's just one of the many things that living on Mars would present us with a pretty big difficulty. And those storms probably have lightning and there's another reason these storms would be really bad, but it has to do with the soil. So, one of the questions we had earlier, before the talk is about water on Mars. And so, our recent rovers, the Curiosity rover, there's an estimate that there is water everywhere on the surface of the Mars, under the polar caps, and then part of the soil from the days when there were oceans on Mars. So the estimate is that for every cubic feet of Martian soil, there's 2 pints of frozen water. It's quite a bit of water on Mars. So again, a remnant of the days when there were oceans. So this is an image from the Curiosity rover. Lots of water up there. The unfortunate for human life there is that another major part of Martian soil is a chemical called perchlorate, which is massively toxic to humans. It's toxic to plants, probably most life forms. So if we do get to Mars and try to live there, that would be a huge problem to deal with, particularly if you think of these planet-wide dust storms. That's perchlorate in the air. So the only maybe benefit of that is that perchlorate is an ingredient that we use in rocket fuel. So if there's, I can imagine if we're living on Mars, there's going to be a lot of terraforming. maybe even seeding, maybe even trying to change the atmosphere, which according to the New York Times, there's some scientists on Earth that are majorly thinking of seeding our atmosphere to deal with global climate change. But it would almost be a necessity for us to go there. Either we would have to create a really, really tight bubble system like on the space station, which is also possible to basically separate us from the outdoors, or we would have to try to change the planet. Um, so I don't need to get into how much Mars has penetrated our psyche, our literature, our movies, our stories, our songs. There's everything out there. It's been a fascination of humanity. Um, but it's it if you think of like collective humanity and the thoughts in the late 1800s, the scientific community was pretty sure that Mars was lush with life and civilizations. Um, that probably spawned a lot of the early stories, images, movies of Martians. So they saw all those canal systems and assumed that it was dug by civilizations. They saw the polar ice caps, not knowing it was, dry ice, assuming that fed oceans. So before we got really, really good images of Mars, there was a pretty good thought that Mars had life and civilizations. And so the whole big question in the whole genre of the media was like what would happen when our two civilizations would meet. But for a long time, that was the thought, even in the scientific community. And it didn't help later when we saw you probably seen this photo from the surface of Mars, invoking something akin to the statues of Easter Island. Uh, I do feel a little guilty. If you don't want it, your bubble burst, you can maybe turn away. But this is that image, um, that we all saw, and then today we have much better images of that same formation. And if you take away the shadows, this is pretty much that same face. Pretty cool, but not an Easter Island statue. Um, I, you know, I I have to bring up Elon Musk again, whether I want to or not. Elon Musk wants to move to Mars. He wants to die there. He wants to be buried there. He thinks it's going to happen in his lifetime, and he certainly has the resources to push the possibilities forward. There is a political drive to move this forward. And, love it or hate it, the injection of private money into space exploration certainly has had the effect of speeding things along. And when you look at all of the things that are happening today, it's SpaceX, it's the billionaires, it's Bezos, it's the Virgin Airlines, Bronson, all of those. It's this private really rich white dudes that are pushing this along. Um, and so that, could mean in our lifetimes, we could see we could get a person to Mars, maybe orbiting and coming back. I think that's certainly possible. And then whether or not we land on Mars, that might be for my kids or grandkids. But it's it's uh it's pushing, and it's not, even when you don't have the political resources, you've got this private group pushing today. So, it's Mars had a pretty good run of being a planet. Even if you just look at from a life perspective or potential life perspective, it had an atmosphere that could support life. But just like Venus, at some point it took a turn for the worse. In this case, it was probably just too small to sustain the heat that you needed in the middle of the planet to keep the rest of the planet dynamic, which is what we have on Earth. Um, so, whether or not we live in a bubble or create the conditions for life to exist there, we probably can. Whether we should or not, is a different question, but we do probably have the know-how and resources to change the planet, which is quite a humbling thought. Um, but humanity is tuned into that station, and we'll see where it takes us. So I thank you for joining me today. I will stop sharing my screen